select injected provider, it will ask which account to connect. So select one of the accounts, then click connect. So at that time, your account will be reflecting over here. Let's see the design of a simple voting contract in Solidity. So what are we expecting through this contract? We are expecting to have such a tabulation, that is for each of the candidates, how much of the votes were polled or how many people preferred those candidates. We need to have such a data structure where this thing is stored. So the best data structure is a key value store where the keys would be the candidate's name and the values could be their total count of votes. So this is what we are trying to achieve through the contract. For that, we need to understand the data structure in Solidity known as mapping. For that, you can refer Alchemy University's lesson on mapping in Solidity. We will just have a reference of that. So this is the resource on mapping. So we are actually constructing a hash table where the hash will be the mapping's key and the values will be stored on the hash table. That's what we are trying to achieve. So this is how mappings are defined in Solidity. You will use the mapping keyword, then you are mapping from one data type to another that you specify over here, then the visibility and the mapping data structure's name. So these are to be mentioned. So what are mappings? Mapping is a key value store constructed out of keys pointing to some values. Okay, so the keys could have a type and the values could have a type. So the possible set of values or the possible set of data types for keys and values are shown here. Then in the syntax of mapping or defining a mapping, you have to specify a visibility within the contract. So it could be public, internal or private. So we will stick with public. Then you have to specify the mapping's name. Okay. So we will discuss a sample voting contract. GitHub link is shown over here. So this is our contract. So contract's name is simple voting and we are defining a mapping from string to unsigned integer 256 which is public and the mapping's name is votes. So votes will be storing a mapping between the name of people and the total votes obtained. Okay. So the keys are all strings. That's the main thing you have to understand, and the values will be integers. There are two functions, one is vote function, other is view votes function. So the purpose of vote function is to increment the vote value corresponding to a candidate. So the logic you can see over here, we are calling or we are accessing the votes mapping for a particular candidate, then incrementing the mapping's value. Okay. Now, if you need to view the votes of a person, how can we do that? So we have to call the view votes function. So it returns an integer, right? So what it is doing, it is actually again querying the mapping or looking into the mapping with the key that we pass as argument. So that's how the contract works. It's very simple. It is using mapping data structure which maps the candidate's name, which is a string, to an integer value, and that integer value corresponds to the total vote that candidate has secured. So in order to increase the vote of a candidate, you have to call the vote function with the name of the candidate so that that particular value could be incremented by 1. And if you want to view the total votes of a person, you can call on that particular mapping with the name of the candidate. The value corresponding value will be taken and displayed. Now the next question is, where will this mapping remain? Mapping data structure, where will it remain? Whether it will remain on the blockchain, whether it will remain system's memory, where will it remain? It actually remains on the blockchain. Okay, now how can we access entries? The values within a mapping could be accessed using the keys. So the syntax for accessing is the mapping name followed by the array index operator, and within that you have to give the key. So in our case, our mapping name is votes. It is keyed using the name of the candidates. So if you want to see the votes Alice got, you have to refer like this: votes, then array indexing operator, followed by with double quotes Alice. Now, how votes gets incremented? So when you call the vote function, the corresponding value of votes for a candidate is taken and it is incremented by 1. Okay. So when you call vote of Alice, what is actually happening? We are actually referring to votes of Alice. Votes being a mapping data structure within the blockchain. So we are taking the votes value of Alice, and as per the operation we are to increment it by 1. So if it is the first time we are calling a vote on Alice, it will be set as 1. So in the data structure, Alice's vote will be set as 1, and she is the only person till now if this is going to be the first invocation of the vote function. So this is how you will put value into a mapping. Now, if you have seen our smart contract, there is a argument of type calldata, okay, or argument of a particular uh, argument of type calldata. So what's the meaning of calldata? Calldata means that the argument candidate is scoped, or its lifetime is only within the invocation of this vote function, and that it doesn't take up much gas. It is optimized just to pass the value to the body of the function. So a gas optimized way of specifying parameters is known as calldata. When we invoke our smart contract, or when we deploy our smart contract, the gas cost for the deployer as well as the gas cost for the person using the vote function will be less when we use calldata, or when we specify the argument as calldata. So it is a gas optimized method to pass parameters to a function, and its lifetime is till the end of the function's execution. Now, how can we deploy and use our smart contract? In order to deploy the contract, you will use Remix ID that we will see in the demo. Then once we are sure that we get a contract address, what we will do, we will invoke the vote function, which will in turn manipulate the votes entry of the candidate, and we can actually view the votes of the candidate. So if you get a flom and failed message, you have to redeploy the contract again, or you have to try redeploying the contract again. Maybe it's due to the gas issues. I have already deployed the contract in this particular address. It's in Sepolia Testnet. You can actually refer that. Now let's see the demo. Okay, now let's deploy the smart contract and interact with it to perform a voting procedure. So what we have to do is, in Remix ID, we need to create a new workspace. So we can use a blank template, give it a name like voting, then click OK. Then already the Solidity code is open over here. You can copy the code. Then you can create a file. You can name it as vote.sol. Then inside that you can paste it. Okay, I have pasted the code. Okay, now if you see here, the Pragma directive is expecting compiler version 0.8.19 and above. Okay, so if you see over here, the Solidity compiler section, it's showing that auto compilation was successful. So if you go over there, it is above 0.8.19. It's 0.8.25. So it's okay. Okay, maybe you can recompile it just to be sure. Then the next thing is, we need to deploy the smart contract on Sepolia Testnet. We are going to deploy it on testnet. Okay, so we need to select injected provider MetaMask. So if you see here, the account information is not getting reflected. Okay, let's try injected provider again. When you select injected provider, it will ask which account to connect. So select one of the accounts, then click connect. So at that time, your account will be reflecting over here. Now we need to deploy the contract. So ensure that the contract name is same as that we have wrote now. Then click on the deploy button. So what you have to observe is, our smart contract is going to take some space in blockchain with this code. So it will cost some gas. So ensure that you have got some Sepolia testnet either with you, so that deployment will be successful. Okay, so click on confirm. So it is being deployed. See, creation of symbol voting is pending. Okay, now there is an option like we own ethers. Can click on that. So if you see here, it is being, contract is being deployed. Okay, so the symbol voting contract is available over here. If you open here, you can see the methods. Right, so what are the methods? Methods are vote and view votes, right? So we will just operate with view votes. Assume that we are trying to see the votes of Alice. So within double quotes, give Alice. Then, okay, then give call. Okay, so the result that we have got is 0 because candidate with the name Alice is not there, right? Because we have not yet voted for anybody. Okay, so what we have to do is we have to now do a vote for Alice. So I'll give Alice, then click on transact. So yeah, we are going to write one vote for Alice onto the blockchain. So that will cost some gas. So approve that. So that transaction is now happening. You will get the transaction hash soon. So before that, we will go to the earlier transaction where we deployed our contract. So if you see here, the details, this contract was created, okay, by our account. So just click on that. So our contract we can see here. Now you can see that a vote transaction has gone through 10 seconds ago. So that was our first vote to Alice. So let's check the first vote to Alice. Okay, so the function call, everything is shown here. Okay, the gas details is there. Then you can see the input as UTF-8. So it's showing as Alice, right? So one vote for Alice has gone through. So that you can see here. Okay. So let's go back. Yeah. So one vote for Alice has gone through. Now let's minimize the vote section. Then we can view the votes for Alice. So we have issued a call. So now you can see that vote is 1. Right. Alice has got 1 vote. Let's try voting to somebody else. Okay. So view votes. We are going to vote, right? So maybe I will vote for a candidate named B or B, Bob. Okay. So the argument is Bob. Then I'm clicking on transact. Now MetaMask will ask you to give some gas. Then only the voting process can happen. So what is the reason? So when you click on when you call the vote function with a candidate's name, it's actually modifying the hash table or it's modifying the mapping, right? We have a mapping named votes that actually maps the name to a number. So that mapping on the blockchain is being changed. So it costs some gas. So that's what is happening here. So let's go to the contract again, see the transactions. Okay, let's go to the contract. Then let's refresh it, right? Let's refresh it. Now we have a third transaction. Let's see that transaction. So what was that transaction? So it's again a call to the vote function. Let's see what was that call like. Okay. So the vote actually went to Bob. So Bob has got 1 vote. I'm calling the view votes over here to check the votes of Bob. So Bob is having 1. So now Bob is having 1. Okay. Now let's vote again to Alice. So I am voting again for Alice. Clicking on transact. Okay, so the vote is going through. Let's see our contract, right? We will refresh the contract. So just now 1 more vote came. So let's see here how many times the vote function was called. It was called 3 times. So this is the latest invocation. Click on the transaction hash to see the details. Show more details, type code, what is going to Alice, right? So let's check the total count of votes that Alice is having. So view votes. Okay, in view votes we will actually call Alice's name. Okay, I am calling it. Now you can see that Alice is having 2 votes. So that is the current voting status. So in this contract, you have to individually call the view votes function for each candidate so that you can actually refer what is being stored in this particular mapping. So that's how this voting contracts work. So the voting contract actually increments the vote corresponding to a candidate when the vote function is called. So the mapping is actually getting modified for a candidate. Then you view that mapping through the view votes function. So this is a typical easy voting smart contract.